So integration by long division is possible on the AB exam and probable on the BC. So if you have it, it's one multiple choice question. The thing that will trigger it is if you see a polynomial over a polynomial and none of the other techniques work, and the degree on the top has to be greater than or equal to that on the bottom. If that happens, you can start doing long division, and it'll make that integrand way easier to work with if you actually physically go divide these. Always look for other methods first, though. I was telling them that if this was just over 2x, it's a part, and we can break it apart and go right to the power rule. U sub's king, so that's going to be all over your AP exam. So always try that first, but that's failing miserably on this one. So on this one, I definitely would try a little long division. So you stick to the left and you divide these. 14x squared divided by 2x is 7x. Put it over its like degree term so that you know when you're done. And then you multiply that 7x back in, and you get a 14x squared plus 7x. Line everything up. Subtract it, which is the same as adding the opposite, whatever floats your boat, and then you knock it down a power. Then you repeat the process, so now I'm going to take what's on the left, the 4x, and divide out the 2x, and I'll get a positive 2. I'm going to write it over its like term, do the same thing, multiply it back in, and I get 4x plus 2. I'm going to subtract my two levels, which is the same as adding the opposite, so I end up with this remainder of negative 7, and I now have a lesser degree than this one. So you do it until you're done with what you have. So then you write that as a remainder. So this would be plus, and we'd have a negative 7 over 2x plus 1. This expression right here can replace the integrand. So technically, if I did a rewrite, when I divided that physically out, I ended up with this minus 7 over 2x plus 1 dx. In sums and differences, you can integrate separately. Products and quotients, you can't, but I can call this 7x squared halves plus 2x. And then when I integrate this guy right here, so I'm not going to do a rewrite, but you're integrating, you're integrating this. This is u sub. U is 2x plus 1. du is 2dx. I need it to be dx, so I'd have a half out front of it, so you can physically go through it. But the 7 comes out front, 1/2 fraction correction. Is mine matching yours? Oh, good. I don't want to make a mistake. I'm the only one who made natural log, absolute value, 2x plus 1, and then Hannah reminded me on the other two I forgot c. And I can't write on that end. So I'm going to put my plus Carl down here. All right? And now it's done. So it's not a difficult technique. It's just sometimes kids forget how to do long division. So that's it for integration by long division. If you are doing this as a video and you want to try another one, we did this one, so you could pause and write it down. And we got x cubed thirds plus 5, natural log absolute value, x plus 2 plus c. And we also did this one, so you could pause and write it down. And we got x cubed plus 5x squared halves plus 5x plus 11 natural log absolute value, x minus 2 plus Carl. All right, Carl.
Yeah.
So